All right, so second time through, because the first time I said the word at least 35 or 40 times, and that's just not acceptable. So I'm going to try this again. Fun fact, I actually failed a presentation when I was a sophomore. It was a presentation about what college we wanted to go to. And I was very, very over prepared in school. So I know that I worked really hard on that presentation probably, but I failed because I said 52 times, to which I argued that wasn't possible, but the rest of the class confirmed that that was indeed true. So here we go. I'm going to do my best to say at all. So this first simulation is the easiest one. It's just the pH scale, and you need to insert the probe so you can read the pH. This one's really easy. You can toggle between different solutions, drain cleaner, soup, coffee, a mixture of different types of everyday acid and bases. And you can add solution here, or you can just add water. You can also remove solution and so forth. So that's all water. Not very interesting, but with something like soap, you might see different things happen with the pH depending on what you adjust. And that's really it for the first one. And then in the second simulation, this one's a little bit trickier. So I try to indicate on the questions what you need to change. So we're not there yet. But those can just be reminders for things I'm going to point out now. It looks similar, but you just have some new information. You have the same solutions to choose from. I recommend leaving this on concentration. You can toggle it to show you information in moles, but that's going to be overall quantity, right? Moles per liter is a ratio. So if I was looking at, let me put this in. I need something different than water. So let me show you guys the difference. Let's put it on concentration. If I add solution here, right, nothing changes. But if I add solution with the quantity, you start to see these numbers climb, right? Because this is an absolute value, it's not a ratio. So I would just leave it here, not to mention we've been doing concentration lately and it's a unit we've been talking about. So let's just continue to practice it. You can also toggle between a logarithmic or a linear scale, and you'll see some very major differences depending on which one you're using. I do ask you about that in the questions. Other features, you can select this button to see the ratio of hydronium to hydroxide. You can't see the absolute numbers of these. Obviously, this is just a representation. I mean, I can count 1, 2, 3, 4 red dots. 4 is not the amount of hydronium that would actually be in this solution. So this is just representation, and as you change to various substances, you'll see different proportions of those ions. If you want to see actual values, you can click molecule count and see the different proportions. So this is water, hydroxide, this is the hydronium, and depending on what you're looking at, those values are going to change. They will also change if you adjust the scenario happening. Okay, so you've got all these different things you can do. And again, I ask you questions about that, and I don't want to give too much away, but that's the gist of what you can do. And then of course, throughout all of that, the pH is going to adjust if there's something happening that is changing the pH. Not everything that you do is going to change the pH. Next up, the second simulation. This is the introduction feature. I'm sorry that the full screen isn't on here for the recording, but the different, oh, that's one. It's not too bad. Okay. The different simulations are at the bottom of the page. Let me reset this one. I don't want to spend a lot of time talking about what you don't have to use. There are features here that you're not going to use. Just stick with what I'm telling you, and we'll be efficient that way without explaining what you're not going to need. So insert pH. Oh, 2. Okay. Still better than like 40. You can select to see solvent here, but I don't think that's very useful. You're just seeing all of the water in the background, so I would leave that off. And then at the bottom of the page, you'll see equations. Right now it's just water, so you're only seeing the autoionization behavior of water. But if I toggle strong acid, strong base, and weak base are different options. A lot of things you can observe. You can observe the equation. You can observe visually what's happening. You can observe the pH. That's all the features of this one. Finally, the most complex simulation. Everything the same, leave the solvent off, leave the pH meter in, you've got the equations, the visual. The only difference now is that you can be a little bit more specific with what kind of acid or base that you're using. I do say on the notes that you could do all of these questions really with using an acid or a base, but we don't have time necessarily to do that. So I just want you to leave it with the acid selected, and then you can change the concentration here. You can go between a weak or a strong acid. Notice what happens to the equations, the picture, the pH when you do that. Also, if you're on the weak option, you can see a gradient. So you can see what happens if you're moving from a weaker to a stronger acid. You can, kind of line up different things. There's a lot of different substances that are acidic, and there's a range of what's considered weak and strong. And remember that the level of dissociation is what determines the strength of the acid. So if something dissociates more, it's going to be a stronger acid because it's donating more hydronium ions. And then again, you can watch the pH as you do that. You can put concentration anywhere you want. So you've got two variables here that you can adjust and see what happens to the pH, see what happens to the equation, see what happens to the visual. So those are the main features of the simulation. Good luck with your questions. I think I only had 2 M's. I'm okay with that. It's a lot better.